Throughout the last term, we have been using a 3 degree of freedom robotic arm. We calculated the forward kinematics using Denevit-Hartenberg notation, and its inverse kinematics were calculated geometrically. We also wrote functions to calculate cubic and quintic polynomial trajectories, as well as computed velocity kinematics, singularity detection, live plotting within MATLAB, and workspace plotting. In order to successfully pick and place the balls, the robot first takes a photo of the workspace. Then, that photo is run through a color mask for each colored ball. Then, that masked photo is then passed into the MATLAB function imFindCircles, which finds the center of each circle and its radius and returns those. Then, we convert the center coordinates from pixel space into the base frame of the robot. Following that, we then do projection mapping to find the corrected location of the ball. Once we have obtained the real-world coordinates of the ball, the arm moves to a position in space just above it, and then slowly moves over it and closes the gripper. Then the arm goes to the home position, pauses for a second, and then goes to the drop-off location, which is denoted by each color. Then the gripper opens and returns home. This process is repeated until the board has been cleared of all objects. For our random object, we chose a blue dry erase marker cap. This was chosen because the color blue was not being used for any of the other balls. In order to successfully pick up the random object, we had to create a new color mask. We made this camera mask only select dark blue, as the camera stand was light blue, and this would cause confusion later on in coding. Because the cap is a different size to the balls, we had to create a new projection function which would account for the difference in height between the balls and the cap. This gave us an accurate location of the cap every single time. In order to dynamically track a ball throughout the workspace, we created a simple function that takes a photo, locates the ball in pixel coordinates, converts them to base coordinates, then does projection mapping. Then the arm moves to the position just above it, and then this repeats roughly every 5 milliseconds.
Oh wait, the arm's not working.